Hi everyone, I'm Dr.M season and welcome to our course, Electricity and Magnetism.
Today, we're going to discuss electrical quantities, and one of these is the electrical current. Electrical current is the flow of charged particles in a certain direction. The charged particles may be electrons, negative ions, or positive ions. They are called current carriers. The symbol used for current is I. Current is the measure of the amount of charge that passes through a given point in the conductor in a given amount of time. The formula for current is equals to charge over time, or I is equals to Q over T. The SI unit of electrical charge is the coulomb. One coulomb of charge refers to the total charge of 6.231 times 10 raised to 18 electrons. Ampere is the unit of current. 1 ampere of current measured at a point means that 1 coulomb of charge is passing that point every second. 1 ampere is equals to 1 coulomb per second. From figure 1, we can see that electrical charges flow through a wire in an electrical circuit. The ampere, often shortened to amp, is the base unit of electric current in the international system of units. It is named after André-Marie Ampère, a French mathematician and physicist, considered the father of electrodynamics. In his experiment, he discovered that when currents flow through two parallel wires, they attract each other and repel each other when currents are made to flow in opposite direction. Now let us proceed to simple electric circuit. An electric circuit is a complete or closed path through which charges can flow from one terminal of an electrical source to its other terminal. A simple electrical circuit has the following essential parts. Number 1, a source or supply. 2, conductors. 3, a load. And number 4, control device or switch. A simple electrical circuit can be drawn using all these symbols. The drawing, which shows how parts are connected together, is called a schematic diagram. From figure 4, it shows some common electrical symbols used in circuit diagram. From figure 5b, it is an example of a schematic diagram of simple electrical circuit. Figure 5a, it shows the actual circuit or the physical device, while figure 5b, it shows the schematic diagram of a simple circuit. Now let us discuss open and closed circuit. If the continuity has been broken by an interruption in the path for current to flow, the circuit is considered to be open. A closed circuit has a good continuity and complete path for the current to flow. A switch is a device designed to open or close the circuit under controlled conditions. An ammeter is a device used to measure the electric current in the circuit. This instrument is connected in series to the circuit. The positive terminal of the ammeter is connected to the positive terminal of the cell or battery, and the negative terminal of the ammeter is connected to the negative terminal of the cell or battery. From figure 8, we can see the conventional flow of current from the positive terminal to the negative terminal of the ammeter. We can see from figure A, the ammeter, from figure B, an ammeter connected in a series in a circuit, and from figure C, the symbol of ammeter in a schematic diagram. Now let us discuss direct current and alternating current. Direct current is an electrical current that flows in the same in one direction through the conducting wire all the time. From figure 10, we can see the current flowing in a DC circuit. Direct current is the constant flow of electrons from an area of high electron density to an area of low electron density. In a DC circuit, electrons move from the negative terminal to the positive terminal of the battery. Alternating current is an electric current that reverses its direction at regularly recurring intervals in which it is moving. Figure 11 shows the AC waveform. Electrons in the circuit moves alternating back and forth about a relatively fixed position. This is done by alternating the polarity of the voltage at the generator or other voltage source. Everything that runs off a battery plugs into the wall with an AC adapter or uses a USB cable for power relies on DC. Examples of DC electronics include cell phones, flat screens, TVs, flashlights, hybrid and electric vehicles. Home and office outlets are almost always AC. This is because generating and transporting AC across long distances is relatively easy. At high voltage, less energy is lost in electrical power's transmission. Higher voltages means lower currents, and lower currents means less heat generated in the power line due to resistance. AC is also capable of powering electric motors. Motors convert electrical energy into mechanical energy. This is useful for many large appliances like dishwashers, refrigerators, and so on. Utility AC can be converted to DC by using a power supply that consists of a transformer, a rectifier, which prevents the flow of current from reversing, and a filter, which eliminates current pulsations in the output of the rectifier. That's all from now. Thank you and keep safe.